In this video, we will talk about summation and sigma notation. So I'm going to start with the definition of series. So a series adds the terms of a sequence. For example, I might have the terms of a sequence A3, A4, A5, up until A57, and the series would add all of those terms together. So we can express this more concisely using something called sigma notation. So if I see this thing, the way I read this, so this symbol right here is the Greek symbol sigma. And then underneath it, I have I equals M, and up top I have N. AI is the formula for my sequence. And the way what this means is first take the number that's written on the bottom, I equals M, and plug it in where the I is. So if I do that, I get A subscript M. And then plug in the next integer up. So the next integer up would be M plus 1, whatever that is. And then start to add those together. Then plug in the next integer up, which would be M plus 2. And keep adding. And keep going like this until you reach whatever number you have written at the top of the sigma, which is N. Okay, so this thing I is something called the index of summation. It represents what we are going to plug in for in our sequence formula. So let's do a practice problem to get a feel for what this means. So in part A, the way I read this is the sum from I equals 2 to 5 of 3i minus 1. So what I need to do is first plug in the value that I have at the bottom in for the I. So if I do that, I get 3 times 2 minus 1. Okay, and then I just keep going. Then I plug in the next value up for I. So plus, which would be 3. 3 times 3 minus 1. And then I plug in the next one, which is 3 times 4 minus 1. And if I keep going, if I plug in 5, I'll get 3 times 5 minus 1. So I started off plugging in I equals 2. Then I plugged in I equals 3. And then so on until I reached this number at the top, which is 5. I equals 5. So I can simplify this. This first parentheses becomes 5. And then I get plus 8. And then plus 11. And then plus 14. And if I add these together, turns out it equals 38. And that's my sum. As one more example, suppose that we have the following sum. So this one starts when I equals 3 and ends when I is 7. This one's a little different because now my sequence formula doesn't have any i's in it. So what is this going to equal? If I try to plug in I equals 3 into this, well, nothing happens. And I just get the number that's currently there, which is 3. Okay. Plus, what about if I try plugging in 4 for I? If I try plugging in 4 for I, well, the same thing happens. There's nothing to plug into, so I just get 3. I just get 3. And then I'm going to keep going like that. Then I try to plug in 5 for I, and I get 3. Then I try to plug in 6 for I, and I get 3. I end when I reach the number at the top, which I'm now at. I'm now plugging in 7 for I, and again, I get 3. So this is when I plugged in 7 for I. And if I add these together, there's 5 of these 3s, so that adds to 15. And that's my value. So this is what this sigma notation means. It's a shorthand way to express these sums.